Okay, so remember, this is what you did in the lab. You take the steps that are on the PowerPoint. You've taken care of most of these in the lab, and it's about getting the last couple of boxes filled on the chart and then answering the question on the next page. To show you how to do that, we're going to take an example, a different example, because the measurements in the lab may not be exactly the same from group to group. So we're going to take a different example. I'll walk you through the last couple of steps that you're going to use to take care of the final product, which is writing the formula for a hydrate. So in order to find the moles of anhydrous MgSO4 from your lab, you can set up your factor label box. The molar mass for MgSO4 is 116.39 grams. Whatever mass you measured of anhydrous MgSO4 that was after heating would go in the top left over 1, and then you can find the molar mass of anhydrous MgSO4. The molar mass of water, like I said in the lab, is 18.01 grams. That way you can fill out moles of MgSO4 and moles of H2O in the data table, and you'll use those numbers to help answer the question on the next page, which is writing the formula for the hydrate. This example is going to show you how to do that. We're going to use different numbers, but this example will show you how to answer that question and how to, in general, write a formula for a hydrate when you are given certain amounts of water that you are going to take out of the compound after heating. So this question right here is using a different compound that's a different hydrate than you used in the lab. But we're going to imagine that you took this compound, copper 2 sulfate, and did exactly what you did in the lab with the magnesium sulfate. After heating, the copper 2 sulfate has a mass of 1.59 grams, less than the 2.50 grams it started with. You know this and happened in the lab with your materials as well. So in order to find the formula and name of the hydrate, the masses 2.50 and 1.59 are important. If you take 2.50 and subtract 1.59, you get 0.91 grams. That is the amount of water that was lost from heating. So the heat was applied to the copper 2 sulfate, the water burned off, and you have an anhydrous form of copper 2 sulfate remaining. You need to subtract these two numbers to figure out the amount of water that was lost from heating. The next step will be to convert the mass of your anhydrous copper 2 sulfate to moles. After that, you'll convert the mass of water to moles. The molar mass that you can use for this question for copper 2 sulfate is 159.61 grams per mole, and obviously use 18.01 grams per mole for water. As you go through and you fill out your factor label box, 1.59 grams of copper 2 sulfate will go in the top left. The molar mass, 159.61 grams of copper 2 sulfate there. That allows you to cross off and eliminate that unit. Divide 1.59 by 159.61 and you get 0.00996 moles of copper 2 sulfate. Do the same thing with the water. Mass of water is 0.91 grams of H2O. 18.01 grams is the molar mass of H2O. you can cross off grams of H2O, divide 0.91 by 18.01, and you get 0.050 moles of H2O. Next, you're going to create a fraction, a mole ratio fraction. Water will always be your numerator in this fraction, and then you'll divide the numbers out. So 0.050 will go in your numerator, 0.00996 will go in your denominator. Take the numbers, divide them out, and you get 5.07. When you took your lowest amount of moles and made it your denominator when finding the empirical formula, you sometimes got numbers like 5.07, something that could be rounded to the nearest whole number. You're going to do the same thing here to find the formula of the hydrate. 5.07 is close enough to 5 that we can round it back down so that you have a near whole number. And for the most part, you will always get a number that's extremely close to a whole number, unless you made a mistake in your math. But for this example, and for the example that is on the, or the question that's on the lab, you should get very close to a whole number. 5 is the whole number in this example. Once you have that math done, you can write the formula. The non-water compound, in this case copper 2 sulfate, is always going to be written first, followed by a multiplication dot. So CuSO4 dot. This is where we will next take a look at the water molecule and the number, the whole number from the mole fraction, from that mole ratio. That will become our big number, or our coefficient in the front of H2O after the multiplication dot. Once you have done that, your formula is finished, and now all it takes left to do is to name the hydrate, which the name of the hydrate is copper 2 sulfate pentahydrate. Remember, your number prefixes from the covalent compound, or the covalent compounds chapter, will apply to all hydrates. The number in front of H2O will be given that number prefix to determine the full name of the hydrate. Okay, here are your practice problems. They're also on Moodle. Remember the instructions to, as you are writing out your practice problems. When you finish, you need to take a picture with your phone or something else and upload it into the assignment module for Moodle. 182 is a tough question. If you get it wrong, it's okay, but the key is that you try to get it right. You try as best you can when you do number 182. If you have any questions, send an email about what you need to do, or if you have any troubles, send an email. If there is no school on Friday, expect something very similar. Remember, if there is school on Friday, the test is on Monday. If there is no school on Friday, the test is on Tuesday.